Okay, so let's prove this trigonometric identity. So first, let's take the left side expression. That is, we write down LHS, and this equals cosecant x cos squared x plus sin x. So first, I'm going to rewrite this cosecant x using the reciprocal identity. That is, one of the reciprocal identity is cosecant x equals 1 over sin x. So I'm using this reciprocal identity to replace cosecant x as 1 over sin x. So therefore this becomes 1 over sin x times cosecant squared x plus we have sin x. And so I can consider this cos squared x as cos squared x over 1. So therefore we will simplify the first term. 1 times of cos squared x is cos squared x, and sin x times 1 is sin x, plus we have sin x. I'm going to consider the second term as a fraction. That is, we can write this as sin x over 1. Now we have to look for the common denominator. We have sin x in the first fraction and 1 in the second fraction. So the common denominator is multiple of these two, which is sin x. And this means we have to multiply and divide the second fraction by sin x. So I do this. So therefore, I write the first term as it is, that is cos squared x over sin x plus sin x times sin x is sin squared x, and 1 times of sin x is sin x. Now notice that we have the common denominator in both fractions, that is sin x and sin x. So therefore we can combine the numerator terms, that is we should add the numerator terms, which is cos squared x plus sin squared x, and this is all over the denominator sin x. Now one of the Pythagorean identity is sin squared x plus cos squared x, and this equals 1. This is a Pythagorean identity, or otherwise we can also say that cos squared x plus sin squared x is also 1. So therefore this is identical to 1, and this means this becomes 1 over sin x. Now we have one of the reciprocal identity, that is the cosecant x equals 1 over sin x, or otherwise we see that 1 over sin x equals cosecant x. So therefore now I can replace this expression, that is 1 over sin x, and this equals cosecant x. And clearly if you look at the given trigonometric identity, this is identical to the right side expression cosecant x. So we see that these two expressions on the left side as well as on the right side are both the same, and this identity is proved.